Now I shall discuss about the fundamental theorem of integration, integral calculus. By this theorem we can evaluate the definite integral, which states that its statement is let f of x be a continuous function. Let fx be a continuous function in closed interval AB. Let fx be a continuous function in closed interval AB. Let capital F of x be the antiderivative of f of x. Antiderivative, or that is known as other words primitive. Let fx be a continuous function in closed interval AB, and let capital Fx be the antiderivative of small f of x. Then a to b fx dx equals to capital F of x from a to b, or that is equal to capital F of b minus capital F of a. This is the statement of the fundamental integral theorem of calculus. By using this, we can evaluate the integration. But suppose the integration is like that, 0 to 1 dx by 1 plus x square. That is the lower limit of the integration, and it is the upper limit of the integration. And here the function is f of x is 1 by 1 plus x square. We know that the antiderivative or primitive of 1 by 1 plus x square is tan inverse x. That is here capital F of x. The antiderivative or primitive of f of x is capital of fx, means here tan inverse x. Then we can directly say it will be tan inverse x from 0 to 1. That is equal to tan inverse 1, put here upper limit, minus tan inverse 0, which will be, we know that tan inverse 1 is pi by 4, minus tan inverse 0 is 0. So the result is 5, or that is pi by 4. That is the value of this definite integration. By using this fundamental theorem of calculus, we can evaluate the definite integration in this manner. For example, suppose the integration 0 to pi by 2 x cos x dx. We have to evaluate this integration 0 to pi by 2 x cos x dx. This, we know that this integration, if this integration is x cos x dx, then we evaluate this integration by using the integration by parts. First we evaluate in indefinite integration method. This is the, and by using the word Italy, here t is the trigonometric function, a is the algebraic function. So this will be the first function and this will be the second function. Next, fix x, integrate cos x dx, minus derivative of x is 1 and integration of cos x is sin x, and integrate both, which is equals to x sin x minus integration of sin x is minus cos x, so that is cos x plus c. We add the constant in indefinite integration here. Now we have to evaluate 0 to pi by 2 x cos x dx, that is x sin x plus cos x from 0 to pi by 2. Just you delete this constant. In case of indefinite integration, we always use the integrating constant, but in definite integration, we cannot use this indefinite integrating constant. Now put x here pi by 2. That is pi by 2 sin pi by 2 cos pi by 2 plus cos pi by 2 minus put 0 in the 0 into sin 0 plus cos 0, which will be pi by 2 sin pi by 2 is 1 cos pi by 2 is 0, so here pi by 2 minus this will 0 but cos 0 is 1, that is pi by 2 minus 1. In this the integration is same process, but in definite integration you cannot use this indefinite integrating constant. So just put the upper limit minus lower limit, you will get the answer, and always it will be a constant. So the value of the definite integration is constant. Another example, suppose the integration is 0 to pi by 2 cos x dx by sin x plus 1 into sin x plus 2. You integrate as a manner. Now we have to put sin x as t. Put sin x as t. Then cos x dx will be dt. If we use the substitution method, then the limit of the integration will change. How the limit of the integration will change? See, here the lower limit is 0. You just put here 0. Sin 0 is 0. Put upper limit here. Sin pi by 2 is 1. So the limit of the integration becomes 0 to 1. That is the change of the limit of the integration by using the substitution. When you use the substitution, you have to change the limit of the integration in this manner. Just you put the lower limit here, then you will get sin 0 is 0. So the lower limit is 0. And if you put pi by 2 here, that is 1. So the upper limit is 1. And instead of cos x dx, you write as dt. And denominator is t plus 1 into t plus 2. Again, how you change the limit of the integration? Carefully note it. Put 0 here. Put the lower limit here. That is sin 0. So the lower limit of the t is 0. And put upper limit pi by 2. Sin pi by 2 is 1. So the upper limit is 1. And instead of cos x dx, we write as dt, and it is t plus 1 into t plus 2. Now we have to evaluate this integration. We note that this integration is evaluated by using the partial fraction. That is the article, integration of the rational number by using partial fraction. Let 1 by t plus 1 into t plus 2 as a by t plus 1 plus b by t plus 2. Then 1 equals to a into t plus 2 plus b into t plus 1. Put t equals to minus 1. Then 1 is equal to a. The value of a is 1 because this term will be vanishes. Put t equals to minus 2. That 1 equals to minus b means b equals to minus 1. Now the integration of 0 to 1 dt by t plus 1 into t plus 2 equals to, instead of a we put 1 here, 1 by t plus 1 dt from 0 to 1 plus value of the b is minus 1, it will be minus 0 to 1 dt by t plus 1, t plus 2. The integration of dt by t plus 1 is, we know that log t plus 1 minus here log t plus 2 mod from 0 to 1, which is equals to log t plus 1 by t plus 2 log a minus log b as log a by b from 0 to 1. Now put t, now 1 in place of t, log 2 by 3 minus log 1 by 2, that is equal to log 2 by 3 divided by 1 by 2, which is equals to log 4 by 3. That is the answer of this definite integration. So in this manner the integration process is same, but you have to evaluate by in the process of definite integration in this manner by using the fundamental theorem of integral calculus. That is Article 9J, fundamental properties of definite integration. Properties. I shall discuss only 3 properties for the Article 9J. In next class, other properties will be discussed. First, the integration of a, if the integration of a to b fx dx, if we change the upper limit or lower limit, then it will becomes negative of fx dx. If you interchange the limit, if it is a to b, if you interchange the lower limit upper limit, then it will be minus of b by a fx dx. Suppose the value of the integration 1 to 0 fx dx is k, then the value of the integration 0 to 1 fx dx will be minus k. That is the basic properties of the definite integration. A to b fx dx is same as minus of b to a fx dx. If you change the lower limit upper limit, then the value of the integration will be changed. Number 2, a to b fx dx is same as a to b f of y dy, which is the same as a to b f of z dz, which is same as a to b f of t dt, like that. The variable has no rules in definite integration. If we change the variable, then it will give the same result. Suppose the value of the integration 0 to 1 dx by 1 plus x square as pi by 4. If we take 0 to 1 dy by 1 plus y square, it will be same as pi by 4. If it is 0 to 1 dz by 1 plus z square, that is also pi by 4. If we change the variable, then it does not play any impact on the value of the definite integration. That is also properties of the definite integration. Another property is if a to b fx dx is same as a to c fx dx plus c to b fx dx, where a less than c less than b. That is also a important properties to evaluate the mod function and bracket function. If we, that is a to b fx dx is same as the a to c fx dx plus c to b fx dx, where c is a point in between a and b. That is also important properties for the definite integration. So first we shall give some examples for the mod and bracket function. Suppose the integration is -2 to 3 mod x dx. How we can evaluate this definite integration? We cannot differentiate or integrate mod x directly. We have to first divide the interval as two parts, -2 to 0 mod x dx plus 0 to 3 mod x dx. One is positive side and another is negative side, because we know that mod x equals to x if x greater than equal to 0 and minus x if x less than 0. That is the definition of the modulus function. Without taking the symbol change, we cannot integrate directly. So first you divide the interval for the positive sides and another is negative sides. Here x is between -2 to 0. So this will becomes -2 to 0, mod x will be minus x dx, because here x is negative. If x is negative, mod x is minus x. If x is less than 0, mod x will be minus x. So if that is the value of the mod x becomes minus x, because mod x cannot be integrated directly. We have to withdraw the mod x, then we can integrate. Next, 0 to 3 mod x. Here x is positive, so mod x is x dx. Now we can integrate directly, which will be minus s square by 2 from -2 to 0 plus s square by 2 from 0 to 3. That is equal to minus, instead of x you put the upper limit 0 by 2 minus 4 by 2 plus 9 by 2 minus 0 by 2, which will be equals to plus 2 plus 9 by 2, that is equal to 13 by 2. That is the answer. So when it is a modulus function, we have to divide two parts, one part for positive and one part for negative. In the positive part, the mod x will be x, and in the negative part, mod of x will be minus x. Then after that you have to integrate. Another examples. Suppose the integration like x minus 2 mod dx from 0 to 4. How we can integrate this? We know that x minus 2 mod equals to x minus 2 if x minus 2 greater than 0, and minus of x minus 2 if x minus 2 less than 0. That means here x greater than equal to 2 and here x less than 2. Then in this way we can divide this definite integration two parts. One part is less than 2 and another part is greater than 2. That is 0 to 2 x minus 2 mod x dx plus 2 to 4 x minus 2 mod dx. In this part, x minus 2 mod is 0 to 2 minus of x minus 2 dx, because this is the negative part for the x minus 2, plus 2 to 4 x minus 2 dx. Now we can integrate in the same manner. That equals to x square by 2 minus 2x from 0 to 2 plus x square by 2 minus 2x from 2 to 4, which is equal to minus of 4 by 2 minus 4 minus 0. If you put 0 here, then total it will be 0, plus 16 by 2 minus 8 minus 4 by 2 minus 4, which is equals to minus 2 plus 4 plus 8 minus 8, it will be 0 minus 2 minus 4, that is equal to minus 2 plus 4 minus 2 plus 4, which is equals to 8 minus 4, that is equal to 4. That is the value of this definite integration. In this manner, we can evaluate the modulus function in definite integration. Another example for bracket x. This property is used to evaluate the definite integration in case of modulus function and greatest integer function. If the function is bracket x, means greatest integer function 1 to 4 bracket x dx. How we can evaluate this bracket x dx from 1 to 4 bracket x dx? We know that bracket x is the greatest integer less than or equal to x, that is known as the greatest integer function or bracket function. In this case, you divide this interval as 1 to 2, 2 to 3, 3 to 4. Bracket x dx, bracket x dx, bracket x dx. You divide the interval as 1 gap. Now 1 to 2, the value of the bracket x from 1 to 2 is 1. We know that the value of the bracket x is 1 if it is 1 less than equal to x less than 2. It is 2 if it is 2 less than equal to x less than 3. It is 3 if it is lies between 3 to 4, like that. N if it is n less than equal to x less than n plus 1. So when we evaluate the greatest integer function, we divide the interval into one subintervals, gap of one subintervals. 2 to 3, 2 dx, 3 to 4, 3 dx, which is equal to the integration of 1 dx is x, 1 to 2, 2x, 2 to 3, 3x, 3 to 4, which is equal to 2 minus 1 plus 2 into 3 minus 2 plus 3 into 4 minus 3, which is equals to 1 plus 2 plus 3, that is equal to 6. Then the value of the integral 1 to 4 bracket x dx is 6. So in this manner, you can evaluate the bracket function or mod function. For your clarity, you have to go through other examples or various type of examples. Then you can evaluate the bracket and mod functions. Suppose the integration is 2x dx from 0 to 3 by 2. How we can evaluate this integration? Instead of dx, x, here it is 2x. Put 2x as t. Then 2 dx is equals to dt. Then dx will be dt by 2. Now the integration becomes, put 0 here. So the lower limit is 0. Put 3 by 2 here, then the upper limit will be 3, and instead of tx, 2x, you write as t, bracket t, and instead of dx, you write dt by 2, and taking 1 by 2 common from the outside of the integration, then the integration is 0 to 3 bracket t dt. Now we can evaluate half 0 to 1, 1 to 2, 2 to 3, bracket t dt, bracket t dt, bracket t dt. which is equals to half into the value of the bracket t from 0 to 1 is 0 dt. From 1 to 2 the value of the bracket t is 1 dt. From 2 to 3 the bracket value is 2 dt. Now it will be 0 plus dt, the integration of 1 dt is t from 1 to 2 plus 2t from 2 to 3, which is equals to half 0 plus 2 minus 1 plus 2 into 3 minus 2, which is equal to half into 1 plus 2, that is equals to 3 by 2. That is the value of the integration from 0 to 3 by 2, 2x dx bracket 2x dx. Another example, and it will be the last example for you. Now you can evaluate the article number 9j and 9i. Suppose the integration is 0 to 2 bracket s square dx. How you can evaluate this integration? Put s square as t, so x is root over t and dx is 1 by 2 root t dt. Now the limit of the integration will change. Put 0 here, then it will be 0. Put 2 here, that is to 4. Instead of s square we write bracket t. Instead of dx it is 1 by 2 root t dt. Now we can divide the interval 0 to 4 as 0 to 1, 1 to 2 plus 2 to 3 plus 3 to 4. From 0 to 1 the bracket value of t is 0 and it will be same 1 by 2 root t dt. The bracket value from 1 to 2 is 1, it will be 2 by root t dt. The bracket value of t is 2 to 3 is 2, 2 into 1 by 2 root t dt. The bracket value of t from 3 to 4 is 3 into 1 by 2 root t dt. First you have to evaluate the value of the bracket. From 0 to 1 the bracket t is 0. From 1 to 2 the bracket t is 1. The value of the bracket t from 2 to 3 is 2 and from 3 to 4 is 3. And this integration will be vanishes. So it will be 1 by 2 root t dt. 1 by 2, that is 1 by 2 dt by root t plus 2 to cancel, 2 to 3 dt by root t plus 3 by 2, taking outside the integration it is 3 to 4 dt by root t, that is equal to 1 by 2. The integration of dt by root t is 2 root t from 1 to 2. It is also 2 root t from 2 to 3. It is 3 by 2, 2 root t from 3 to 4. Now putting the upper limit, cancelling 2 and half, that is root 2 minus 1 plus it will be 2 root 3 minus 2 root 2 plus cancelling 2 2, here it is 3 into root 4 means 2 minus root 3, which is equals to root 2 minus 1 plus 2 root 3 minus 2 root 2 plus 6 minus 3 root 3. That is equals to, first term is 6 minus 1, that is 5. Here it is minus root 2 minus 2 root 2, that is equals to minus root 2, and it is 2 root 3 minus 3 root 3, that is root 3. That is the answer of this integration. 9J, indefinite integration. Thank you all.